Here's a question that was emailed to me. Let me share a screen because I did type it for you right here. The weekly revenue of a business selling gummy bear bags is a function of price, okay? We know that the weekly revenue is $9,843 when the price is $1.70. The revenue is $5,112 when the price is $3.60. Assuming that the weekly revenue is zero, when the price is zero, find a quadratic model that fits this information. Okay, let me go ahead and stop share and get my iPad involved so I can write the answer or the process down for you. All right, so what is it that we know about any quadratic function? We know that any quadratic function, f as a function of x equals ax to the second plus bx plus c. Or, you can think of this as y equals ax to the second plus bx plus c. And of course, in this case, we are talking about revenue being a function of price. So I can say that revenue as a function of price equals some a p to the second plus some b times p plus c. And so let's work with this. All right. The numbers that were given to us, let me go to the next page and use those numbers and write down the equations that we can. So for one thing we know, let's make this equation 1, that the revenue was $9,843 when the price was $1.70. So plus some b times 1.70 plus c. We also know that the revenue was $5,112 when the price was $3.60. Okay. And finally, equation 3, we know that there was no revenue. The revenue was 0 when the price was 0. So a 0 to the second plus b times 0 plus c. And notice that the last equation is very helpful because now I know c equals 0. So this c equals to 0 and this c equals to 0. It makes makes my life easier. Having said that, let's go to the next page and rewrite this equation so we can simplify this, like here, what's the square of dollars 1.70, what's the square of 3.60? Going to the next page, so I can rewrite the equation 1. I know 9,843 equals 2.89, which is the square of 1.7 a plus 1.7 b. We know, let's have the other equation 2 is 5112 equals square of 3.6 is 12.96 a plus 3.6 b. Remember, I'm not going to write down plus 0. It's just not necessary. So at this point, I'm going to go ahead and use substitution. You can use elimination or, but I think I'm going to go ahead and use substitution. I'm going to go ahead and solve for this b right here from equation 2. So solving for b from equation 2. Subtracting 12.96 a from both sides gives me, let's see, 3.6 b equals 5112 minus 12.96A. And let's divide both sides by 3.6. So B equals, here's my calculator, 51112 divided by 3.6, 1,420 minus 12.96 divided by 3.6. Okay, give me another 3.6A. So I know B equals 1,420 minus 3.6A, and I can go ahead and substitute it right into equation 1. So I'm going to sub into equation 1. Let me go ahead and go to the next page. Now, equation 1, I had 9,843 equals 2.89A plus 1.7, and B we decided was 1,420 minus 3.6A. All right, so let's distribute. So I get 9,843 equals 2.89A plus 1.7, and grab my calculator again. 1.7 times 1420 gives me 2,414 minus 1.7 times 3.6, and that is negative, so 6.12A. Okay. And so let's do this. Let's subtract 2,414 from both sides. And let's combine these two. They are like terms. Okay. So 9,843 minus 2,414. So it gives us 7,000. Yeah. 7,429 equals 2.89 minus 6.14 gives me minus 3.23A. Okay, so let's divide both sides by negative 3.23, and that gives me A equals 7,429 divided by negative 3.23A. Oh, I'm getting, okay, didn't give me any decimals. Nice, 2300. Negative 2,300 is the value of A. So now I know the value of A. Now I need to find the value of B. Remember that we said that B, we just solved for B from equation 2, and we said B equals 1420 minus 3.6A. So B equals 1420 minus 3.6 times minus or negative 2,300. Okay, so 1420 minus 3.6 parenthesis negative 2,300, and that gives me 97, positive 9,700. So B equals positive 9,700. So we know that, so the final answer, okay, that we said R as a function of price equals A, that was negative 2,300, P to the second plus 9,700. P is the final answer. Once again, I'm not going to write down plus 0. It's just not necessary. Let me know if you have any questions, and thank you.